Hey folks, in this video we're going to look at 7.3 day 1, in which we look at solving rational inequalities and equations, as well as look at some applications of rational functions. Alright, before we dive into these scenarios, we're going to take a look at some solving strategies. First up, we're going to look at a rational equation. In this first problem, we can see that equal sign in the middle. We have a rational expression on the left and a polynomial on the right. It's important to remember that all polynomials really are rational expressions. A polynomial function is a rational function where the denominator is 1. So that right-hand side, the polynomial x plus 5, I can rewrite as x plus 5 over 1. After reconsidering that polynomial to be a rational function, the proportion is a little bit clearer. A proportion is two ratios that are set equal to each other, and we solve proportions through cross multiplication. So I'm going to go ahead and do that. I'm going to multiply x plus 5 times x plus 1, and on the right hand side I'm going to multiply 1 times 2x plus 17. In solving from here, my next step is going to be to FOIL out the left-hand side. And if I do that, I'm going to get x squared plus 6x plus 5. On the right-hand side, distributing that 1 is going to keep the right-hand side 12x plus 17. Now in this next step, now that I've FOILed out, I can see that I have a quadratic from that leading term of x squared. So solving quadratics, we have two options. We can factor or we can use quadratic formula, but before we can use either of those options, we have to move everything to one side. I have to set this equation equal to 0. So I'm going to do that next by subtracting 2x from both sides and subtracting 17 from both sides. And then after I move everything over to one side and set it equal to 0, it'll be easier for me to decide what solving strategy to use from here. Alright, so it looks like this is going to be factorable, so I'm going to check, find two numbers that multiply to negative 12 and add to 4. That would be 6 and negative 2. So this factors into x plus 6 times x minus 2. And then using the zero product property, I can set each of those factors equal to 0 and solve. We get two solutions of negative 6 and positive 2. It's always a good idea to check your answers by plugging it back into the original statement. So I'm going to go ahead and do that with both of these potential solutions before I decide if they actually are solutions or not. So first I'm going to plug in negative 6. On the right hand side, we're going to get negative 12 plus 17. Which is a positive 5. In the denominator on the left-hand side, negative 6 plus 1 is negative 5. On the right-hand side, negative 6 plus 5 is negative 1, which gives me the statement of negative 1 is equal to negative 1. So I know the x value of negative 6 is a solution. Okay, I'm going to erase this, and then I'm going to check the second solution to make sure that that one works as well. Plugging in a positive 2. In the numerator on the left-hand side, we get 4 plus 17, which is 21, over 3. On the right-hand side, we get 7, giving us the statement 7 is equal to 7, which means that both of these values for x are solutions to our rational equation. Alright, next we're going to consider the inequality. We can see that less than or equal to statement in the middle. And we can approach inequalities in the same way, where we just solve directly for x. Instead, we're going to think of it kind of from a graphing scenario in which we set one side equal to 0, and then we look for the positive and the negative y values. So let's start there, and then after we get it set equal to 0, I'll explain a little bit more. So I'm going to set it equal to 0 by moving everything to one side. In this case, I'm going to subtract 5 and add x to both sides. And then I'm going to simplify the left-hand side by getting a common denominator and then adding all of those expressions together. So I need to multiply both x and this negative 5 by x over x so that I have a common denominator. This is going to give me 3x minus 15 over x plus x squared minus 5x all over x. Now that I have a common denominator, I can go ahead and add those together. Adding across the numerator, we get x squared minus 2x minus 15 all over x is less than or equal to 0. Now, in the past few lessons, we've been graphing these rational functions. And so I know that I can find the asymptotes and the intercepts for this rational function. If I think about the part of the graph that I want, I need to consider the inequality that we are working with. And the inequality here is less than or equal to 0. So what that means is that on the graph, I want all of the parts of my graph that are going to fall below the x-axis or on the x-axis, because that's where the y values are 0 or negative. So I need to know which parts of my domain, which x values, produce y values that are either equal to 0 or are negative. And to do that, we're going to use kind of that last step of graphing, which is to use the sign diagram. In graphing, we use that sign diagram to find additional points on our graph to create the curve, but here we're just going to be looking to see which intervals have either a positive or negative y value. And for us, our solution is going to be anything that has a negative y value or is equal to 0. So in the sign diagram, we plot the vertical asymptotes and we plot the x-intercepts. So those are the two things that I need to find for this function. I don't need to graph the whole thing. Of course you could, that would be another method to solve, but to be the most efficient, I just need to find the vertical asymptotes and the x-intercepts to make my sign diagram. So I'm going to go ahead and factor that rational expression on the left. The numerator is factorable. It's going to factor into x minus 5 times x plus 3. And my denominator is x. Okay, the denominator is what gives me the restrictions. So I know x cannot equal 0. Since there's no matching factor in the numerator, I know that that is a vertical asymptote, and that's one of the values that's going to go on my sign diagram. The numerator is what gives us our x-intercepts. If the numerator is equal to 0, 0 divided by anything is going to be 0, as long as the denominator isn't also 0. So my x-intercepts are going to come from this numerator. We're going to get an x-intercept at 5 and an x-intercept at negative 3. So those are both going to go on my sign diagram as well. Okay, and again, your sign diagram is just a number line that allows you to test for intervals, and the intervals are going to be created by the vertical asymptotes and the x-intercepts. So I have an x-intercept at negative 3, we have a vertical asymptote at 0, and then we have another x-intercept at positive 5. This gives us 4 intervals to check. We're going to check the intervals by plugging in an x value that fits in that part of the domain to see if the y value is either positive or negative. So I'm going to start on the far left. I'm going to pick an x value less than negative 3. I'm going to plug in negative 4, and I'm going to plug it into the factored version of that expression on the left-hand side. That gives me negative 9 times negative 1 all over -4. And again, I don't care about the specific value. I just care if it's positive or negative. If I was actually graphing these points, I would want to know the specific y value, but here I'm just looking to see if it's positive or negative. So my numerator is going to be positive. Negative times a negative gives me positive. My denominator is negative. A positive divided by a negative ultimately gives me a negative interval, a negative y value. Right? I'm going to repeat this process for the next 3 intervals, picking x values that fall in that part of the domain, plugging them in, seeing if the y value is positive or negative. So next up, I'm going to use -1. Plugging that in, I get -6 times 2 all over -1. That gives me a negative divided by a negative, which ultimately is a positive. So that second interval is going to have positive y values. Up next, I'm going to check an x value of +1 for the third interval. We get -4 times +4 divided by 1. That's going to give me a negative divided by a positive, which is going to be a negative y value. And then last, we have some x value bigger than 5. I'm going to choose 6. That gives us 1 times 9 all over 6, which is a positive divided by a positive, giving me a positive interval for the end. Okay. Now again, based off of this inequality, we wanted the y values that are negative, those that are less than 0. So I'm going to pick these 2 intervals. And then I also wanted the x-intercepts because I want the values of x that do give me a y value of 0. So I want to keep those x-intercepts. So I'm going to keep -3 and I'm going to keep +5. 0 does not get to be part of my solution because it is a vertical asymptote. That x value is not something that I can plug into that expression on the left-hand side. Otherwise, I'd be dividing by 0. So I'm going to define my solution in interval notation. The first solution interval is from -∞ to -3, square bracket because we're including -3. Joining that with the union, the second interval is from 0 to 5, parentheses on 0 because again that's an asymptote, that can't be a possible x value, and then ending at 5 with a square bracket since that's where it's equal to 0, and this would be my solution set. All right, so now we're going to look at some other scenarios in which we can write rational expressions to define a situation and find a solution. I'm also going to teach you a couple other methods for solving equations that have rational expressions in them. So this first scenario is for the world famous Nathan's hot dog eating contest. It takes place in the summer. If you have not seen it, I'm not sure that I'd recommend it, but it is fascinating, I'll say that. And so in this contest, people eat as much as they can, as fast as they can. There actually is a major league for these eating contests. Like I said, it's fascinating. So in these contests, some of the biggest names are Esper and Chestnut. Those are real people. Those are their last names. And Chestnut currently can eat 70 hot dogs in 10 minutes, which is absolutely amazing. Together, both Chestnut and Esper can eat 100 hot dogs in 8 minutes. Now, using these rates, we want to figure out how long it will take Esper alone to eat 30 hot dogs. All right, so really we have 3 rates here. We have the rate of each of these individuals alone, and then we have their combined rate. And if we were to take each of their individual rates and add them together, we would get the combined rate. One of the biggest things about setting up these rates is we have to make sure that we are consistent. So we're going to define these rates as hot dogs per minute. Okay, so Chestnut alone can eat 70 hot dogs in 10 minutes. Okay. Together, it says that they can eat 100 hot dogs in 8 minutes. And what we're trying to find is the time it will take for Esper to eat 30 hot dogs. So we have 30 over x, and x is ultimately what we're trying to find. Now, one option to solve this equation would be to get a single expression on the left to get a common denominator, add those fractions together, and then use proportions, cross multiplying. That will work here. What I'm going to show you is a method called clearing fractions, and it's a way to turn this into a linear equation that doesn't have any denominators. And to do that, we're going to multiply the whole thing by every denominator that we see. So I'm going to keep this equation balanced by multiplying everything by the same values. I'm going to multiply them all by 10, by x, and by 8. Right? And in doing that, we're going to effectively clear the fractions. In the first term, right, we'd have 70 times 10 times x times 8 all over 10. In the second term, we're going to have 30 times 10 times x times 8 all over x. And in the last term on the right side, we're going to go 100 times 10 times x times 8 all over 8. Okay. And you'll notice that these expressions all are going to have a common factor that we can simplify out. Right? In that first term, our 10s are going to simplify out. 10 divided by 10 is 1. In the second term, the x's are going to simplify out. And in the last term, the 8s are going to simplify out. So I'm going to be left with something that doesn't have any denominators. They've all been cleared out. So in that first term, we have 70 times x times 8. That's going to give us 560x. Right, my x has disappeared in the second term. 30 times 10 is 300, times 8 gives us 2400. And on the right hand side, our 8's have disappeared. We're left with 1000x. And now I have a linear equation without any denominators. I'm going to go ahead and subtract 560x from both sides. I get 2400 is equal to 440x. Dividing both sides by 440, right, we'll get 5.45, which represents the amount of time in minutes that it will take Esper to eat 30 hot dogs. All right, for our last scenario, we're going to follow the story of our friend Carl the adventurer. Carl is out canoeing, trying to find Sasquatch, because what else would Carl be doing? It says that he starts out at his base camp, and he canoes down a river 5 miles to try to check out this Sasquatch nest. Sadly, he does not find anything, so he turns back around, goes up the same way he came, another 5 miles, back to camp. The data that we have here says that it takes him 3 hours to leave and come back. We also know that he canoes a rate of 6 miles per hour in still water, so that would be without any current flowing. He's in a river, so there is current flowing either with him or against him, depending on the direction he is traveling. And we want to know, what is that current? What's the speed of the river flowing that day that he sets out? So we need a consistent thing to compare to build this equation. And so the data that we have there is the total time that it takes him to get to the nest and back. So we have the total time is 3 hours, and we know that that must be the time that it takes him to go downstream plus the time that it takes him to go upstream. We also have the distance. We have 5 miles in each direction. All right, we know distance and time are both related to velocity. So kind of a key part of this is to know that velocity is distance over time. All right, and if we're trying to solve for time, I can rearrange those variables to say that time must be distance divided by velocity. Now his velocity is going to depend on which direction he's traveling. When he's traveling downstream, that velocity is his speed of 6 plus the current. The current is going to push him, and I'm going to use C for the current. Ultimately, C, the current, is what we're trying to solve for. His velocity on the way back is going to be a lot slower. He canoes 6 miles an hour, but now the current is going to slow him down, so his velocity is going to be 6 minus C. So that means the time that it took him to travel downstream is going to be the distance, 5 miles, divided by the velocity, 6 plus C. The time it took him to go upstream is 5 miles, divided by the velocity, 6 minus C, and that total is 3 hours. Okay, I'm going to solve this using the clearing fractions method. So I'm going to take that entire equation and I'm going to multiply everything by the same value so that I keep it balanced. The denominators here that I want to multiply by are 6 plus C and 6 minus C. Okay. When I multiply it into the first expression here, I know the 6 plus C is going to simplify out, so I'm going to be left with 5 times 6 minus C. In the second expression, that denominator of 6 minus C is going to divide out with the factor of 6 minus C. So I'm going to be left with 5 times 6 plus C. And on the right-hand side, I don't have any common factors, so both 6 plus C and 6 minus C are going to stay. And so now I don't have any fractions that I have to work with, but I do have a lot of things to expand out. So I'm going to multiply out this left-hand side, distributing the 5 in each of those expressions. And on the right-hand side, we have 3 factors, so we need to distribute and FOIL. I'm going to distribute first, and then FOIL. Going back to the left-hand side, I see some things that are going to simplify out. Negative 5C, positive 5C are going to disappear, so I'm going to be left with 60. And then on the right-hand side, we need to FOIL. So starting with 18 times 6 is going to be 108. Then we have 18 times negative C. On the inside, we have 13C times 6. That's going to give me another 18C, this time positive. And then the last, I'm going to get negative 3C squared. Okay, so the right-hand side, we're going to have some stuff that's going to simplify out there as well. The negative 18C and the positive 18C are going to simplify to 0. So I have 60 is equal to 108 minus 3C squared. From here, I'm going to solve for C by isolating that variable. I'm going to subtract 108 from both sides. I get negative 48 is equal to negative 3C squared. Dividing both sides by negative 3, I get a positive 16 is equal to C squared, which if I take the square root, I should get positive or negative 4. The positive versus negative in this case represents the direction of the current. When it's going against him, we would consider that negative. When it's going with him, we'll consider it positive. If we're just talking about a velocity, we would just say positive for, what were our units? Miles per hour. All right, so there are some examples of applications of rational expressions and equations and inequalities. In a lot of these, you're going to be asked to write the equation and then solve it. You can solve it using proportions or using the clearing fractions method.